we have been doing what types of compounds? Learning to write the formulas for what type of compounds? Ionic compounds. And how did we recognize them as ionic? There were metals in them, with the exception of the ammonia. Okay? But there were metals. And as soon as we saw a metal, we knew we were going to look at the charges and use the charges to figure out how many of each of the ions we need, right? As it turns out, for over 80% of you guys, that turned out to be a fairly easy process. You get what to do. You may not know your ions real well yet, but you know the process. Fair enough? Okay. I also told you that there's a set of rules or a system that we use for covalently bonded compounds. That is also a very simple process. You guys are going to get it. It's easy. But now, just like with the significant figures things, where there's a relatively easy set of rules for addition and subtraction, and a relatively easy set of rules for multiplication and division, where you guys are screwing up is using the wrong rules for the wrong things. Same thing could possibly happen here. So you really have to start thinking to yourself, is this an ionic compound or is this a covalent compound, and use the appropriate set of rules. Here's what we're going to do. We're going to look at binary covalent formulas. We're going to both name and write them. We're going to write the formulas and name the compounds. Binary covalent, that tells us two things. How many elements are going to be involved in a binary compound? 2. What types of elements are they going to be? Both of them are going to be nonmetals. So there you go. That is as far as we're going to go in this class with the covalents. Okay, just binary covalents. Everything else we'll save for later date. All right, anyway, this is a really simple rule. We're going to use prefixes to determine how many of each element. Now, with the ionic compounds, go write this down. Anyone want to take a stab as to what the formula for sodium chloride might be? NaCl. What about the formula for, say, magnesium chloride? Well, it'd be MgCl. Remember, this is 2 plus, this is 1 negative. MgCl2. That was probably on at least one of your assignments at some point in time, right? And what about aluminum chloride? Al with A, and it ends up being AlCl3. That was also probably one that we had done somewhere, okay? So how many different combinations of sodium and chlorine can we make? 1. How about magnesium and chlorine? 1. And how about aluminum and chlorine? 1. There's only one way those things combine, okay? Where I'm going with that is, with the covalent compounds, there's multiple ways a lot of the elements can combine. You guys remember the law of multiple proportions from chapter 3? Okay, there were 2 test questions that had something to do with that, and then on the review packet there was, I think, NO, NO2, and N2O. Anyone vaguely, you had to look at the ratio of the masses to each other. That demonstrated the law of multiple proportions. So with the covalent compounds, any 2 elements have a tendency to form more than 1 compound. So we can't just rely on their charges. So now we're going to come up with a number of ways of figuring out, or a different way to figure out how many of each of those elements, and that's by using these prefixes. So every element in a covalent compound, every symbol in a covalent compound is going to have a prefix indicating how many of each element in the name. The exception to that is if there's only one of the first element. That's the only time we're not going to use a prefix. You guys actually are very familiar with that, you just don't know it yet. I'll tell you about it here in a little bit, okay? Those are the prefixes that we're going to use. You guys are probably familiar with probably like 6 to 7, possibly 8 of those. Mono, I think you guys knew was 1. Were you guys familiar with that? Everybody knew di, I think is 2, right? Tri, you probably knew is 3. Did you know 4 was tetra? Some of you did, some of you didn't. Those of you that didn't, I'll bet you did and didn't know it. Did you guys ever play a little game when you were a kid, or yesterday or last period, where you had this little game where you had these little shapes that were in different, and you had to stack them all up so that they all fit together and made like a big tower? What's that called? Tetris. And each of those little shapes had how many blocks? Hence the name Tetris. There's 4 blocks per shape, right? Okay, so tetra is 4. 5, you guys hopefully knew from the pentagon. 6, you may or may not have known. You know 6 was hexa. Okay. 7, you may not have known was hepta. Some of you did, some of you didn't. Octa, I think everyone knew, either from an animal, or from a stop sign, or from watching fights on television.
Yes.
Okay. 9, you may not have known. Did you guys know 9 was Nona? That one most people don't know. And then 10 obviously is Deca. Anyway, you need to know those prefixes. So there you go. Like I said, most of them you already know. All right, so, and the second rule is the second element, remember it's a non-metal, always has its name changed to IDE. Well, hey, we've been doing that anyway. What's the name of the oxygen ion? Oxide. F is chloride. Cl is chloride. N is nitride. So you guys already know that piece. You know what I'm saying? No, that's a whole nother. The carbon has its own branch of chemistry. It's called organic chemistry. That has its own thing. Anyway, moving on. There is a carbide, but we're not going to talk about it. Okay, wow. Let me walk through a set of 4 examples to start off with, and I'll give you some that we'll learn it with these 4, and then we'll branch off and have you guys try some on your own. Okay, write down those formulas, and then we're going to walk and talk through how to come up with their names. First of all, are any of those ionic compounds? I see a lot of people shaking their heads no. Why? How do you know they're not? There's no metal. Would you agree? Okay, so that means we're going to use prefixes to tell how many of each of those atoms is involved. Because otherwise, with ionic compounds, we didn't need that because you could only form one combination. Here, obviously, we have at least 4 combinations. So, following the rules that every element gets a prefix, except if there's only one of the first element, what will be the name of this one? Well, there's only one of the first element, so we're just going to say nitrogen. The second element always gets a prefix. So, how many oxygens are there? 1, so it's going to be monoxide. Now, you guys are already familiar with a similar compound, or a similar name anyway. Carbon monoxide. Now you know why it's called carbon monoxide. Okay? This next one. Anyone want to take a stab here? Nitrogen dioxide. Hi. How are you?
I'm great.
You weren't here today again.
No, I was late.
Yeah?
Yeah. But I have my homework.
Excellent.
And it was due today, right?
Oh, yeah.
Okay. Look, I actually did.
Yeah. Oh, look at that.
Yeah, except for that.
Okay, we had a wonderful discussion today.
So you're not, this isn't.
Oh,
Okay, all right.
and if I don't,
Then just let you know.
let me know.
All right.
All right, thank you. Nitrogen dioxide. Does that sound familiar? Another compound that you guys are familiar with? What's that? Carbon dioxide. Hopefully you guys have seen why we were calling these things this way. Now what are we going to do? Dinitrogen monoxide. Very good. lastly,
Same thing.
dinitrogen.
Penoxide.
Well, here's what we're going to do. I'm going to let you do this.
Yeah, that's what it is.
Dinitrogen pentoxide.
Penoxide. Say fast.
Fast. Or it.
Okay.
What? You said say it fast.
Nah, you don't play, man.
We don't bring the ale along?
Don't have to. In fact, don't. Don't bring the A along.
Like ever?
Ever. Well, no, that's not true. Seriously, honestly, that question will be answered by yourself when you're writing them out, because you're going to say it and you're going to go, ooh, that's dumb. Seriously, it's going to happen. All right, moving on. How do you guys feel about this?
Good.
That's pretty darn easy, isn't it? All right, let's mix and match here a little bit. I'm going to give you 4 or 5 more. I'm going to give you 2 or 3 of the formulas. You write the name. I'm going to give you 2 or 3 of the names. You write the formula. Okay? So here we go. I got to make these up though. Okay, here goes one. I'm actually having a hard time thinking of compounds. Oh. I think that'll fill the bill there. And tomorrow we get to go back to dimensional analysis and conversion factors. Just kidding, I just want to see if I can get a groan from you. I got no groans. All right. Are we fini? Yes, Victoria.
Okay, so like sulfur trioxide.
Yeah, we'll talk about that when we get there, okay? Good. You know, I can't figure you out yet. Sometimes you think. That's good. You just don't think often enough. Here we go. SCl3. Is this ion? Oh, I forgot. Darn it. There's one more I wanted you to do. Darn it. Are you guys done with these? Yeah, okay. Silly on my part. I'll put this one down too.
Another one?
Like I said, I forgot one, but anyway.
Oh, you about to say?
Alex, I like your idea there. Yes, Morgan, you're right. Just keep this conversation between you and I, okay? But yes, Morgan, you're right. All right, here we go. SCl3. Anyone want to take a stab?
Salt.
Sulfur,
Tri.
trichloride. Anyone want to take a stab on the next one? Di what? Chlorine. And next? Heptoxide. How many of you have the first two correct? Awesome. Look at you guys go. This is easy, isn't it? Next one, phosphorus pentachloride. Anyone?
PCl5.
Yeah. Sulfur trioxide. SO3. Now, go ahead and ask your question, Victoria. No, it's not. That's sulfite.
The charge, obviously.
Yes, that means this species has 2 more electrons than that one does. We're going to deal with that as far as it comes to drawing a structure for these things later. Okay, but that was good. You're the first one today. It's actually, I had to bring that up in my other class. Nobody else recognized it. So that's why I said that was a good job of thinking. Okay, but there is a difference the way these things, well, a clear difference is this one has a charge. So this one will not exist by itself, whereas this one can exist, or does exist by itself.
I thought everything had a charge.
No. And then lastly, Al2O3. Morgan?
Wait, what?
Very good, Morgan.
Wait, what is it?
Say it a little bit louder. Aluminum oxide.
I thought Sagan said 2.
Morgan, why? I didn't hear. I was looking at you and I saw nothing. So. Aluminum's a metal. That's an ionic compound.
Got it.
As I said earlier, from now on, you guys are going to have to look at each and every element or every compound and make a decision as to whether it's ionic or covalent. Because from now on, they're not all going to be from one type or another. It's going to be all mixed and matched by the time it's all said and over. You have to be able to recognize that. You guys with me? Very good case in point. How many of you actually put aluminum oxide? Okay, good. I saw you pick up on it first. I was watching. You looked at your periodic table and went, Okay, moving on. Very good. Would you guys agree that's easy? Good, we're done with that. Next. Acids. Once again, acids, in my opinion, are easy. But it's a whole different set of rules and guidelines. So now we're going to have 3 separate things. We're going to have ionic compounds, we're going to have covalent compound, binary covalent compounds, we're going to have acids. Each of them by themselves is pretty easy. Like I said earlier, just recently, we're going to start mixing and matching these things very, very soon. Let me see. There's a whole blurb at the bottom of page 5 that talks about naming and writing acids. I said 5, didn't I? I meant page 4. I am not going to read through that. However, you are responsible for that. I'm just going to show you how to do it. This just gives you more details. Moving on. Looking at page 5 now. To explain acid naming, we're going to use those 5 hydrogen, chlorine examples. Okay? First one we're going to do, first of all, to be an acid as far as our class is concerned, actually for this chemistry class and the next one that you take, a substance will be an acid when it's dissolved can be an acid if it's dissolved in water. There's other pieces that need to be involved, you'll see that here shortly, but they're only going to be considered acids when they're dissolved in water. Okay? Next, HCl. We're going to call this a binary acid. Why are we going to call it a binary acid? Because there's only 2 elements. Okay, but here's the thing. There's one element you're looking for to determine if something is an acid or not. Looking at that list at the top of the page, what element do you think that might be? What element is going to tell us that a substance could be an acid? What? Hydrogen. If the name of a formula starts with hydrogen, you are going to consider it an acid. Okay? If its name has the word acid in it, this is a toughie, you're going to consider it an acid. And its formula will then start with hydrogen. You see where I'm going with that? There we go. So, in a binary acid, there's only going to be two elements. One of them is hydrogen. And remember, hydrogen forms what charge? A 1+ charge. Okay. So, we're going to treat these like ionic compounds. What we're going to do, if it's a binary acid, two elements, we're going to write the prefix hydro. So, with HCl, it's an acid, formula starts with hydrogen, it's binary, there's only two elements. So we're going to write hydro. Well, don't underline it. We're going to write hydro. Then what we're going to do is write the root of the anion, the negatively charged ion. Chlorine, the root of chlorine is chlor. And then we're going to, whoa, that was weird. We're going to write the suffix ic. And lastly, we're going to write the word acid. There we go. Hydrochloric acid. Now, you guys have all heard of hydrochloric acid. In fact, we used it in one of our labs, right? It's also in your stomach. So, there it is. That's why the word or phrase hydrochloric acid comes about. Let's look at some more examples. I think I gave you what? HF, HBr, HI, blah, 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 blah. Yes.
So, no.
Are you sure?
I'm pretty sure you'll get to it.
You're pretty sure what?
That you'll understand.
Yeah. So let's do. So I think were there 5 examples there? Right? Okay. Could you guys please take a moment? 1, 2, 3. Yeah, there are 5. Please take a moment and see if you can come up with the names of those 5 species. HF, HBr, HI, HCN, and H2S. Do I have any food? I'm hungry. No?
Got an orange.
I don't do that.
Wait, what? Bruh.
Nope. Do the best you can. What happens if you get it wrong? How's that going to change your life today? What's that? I'm not going to hold your hand. So you can figure it out. I'm sorry, what? Yeah, those, is it 4 or 5?
It's
5. Try those 5 on there. Was HBr next? We'll go with that. Was HI in there somewhere? Was HCN in there somewhere? How about H2S? Did I miss one? HF? I High frequency. Oh. No. No. Think about it. Figure it out. If you get it wrong, it doesn't matter. Take a chance. You don't take chances very much, do you? Do you? You walk in this class every day. That's taking a chance. Shelby, done? Okay. David, done?
Yeah.
You look like you're thinking.
No, I'm done.
Okay. Or sleeping, which one?
Actually, I'm David.
Oh, is this what I call you? Jordan, done? Did you start?
Yeah, I've started.
Excellent. Allie, done? Let's go. Oh, Josiah, what'd you get for HBr?
Hydrochloric acid.
Yes. How many words?
2.
Yep. Mallory, what'd you get? Did you get that? You don't think it's right? Do you have the word idiotic in there? Excellent. Go for it. Hydroiodic acid. Is that what you said? Awesome. That's precisely it. Not hydroidiotic acid. I've seen that before. Is that what you're asking me about? Wanted to ask me about? No. Okay. By the way, it's very likely from this point forward, if I see you in the hallway, I might say to you, hydroiodic acid.
Yeah, I see.
And you and I will have a little secret amongst ourselves. Okay. Next, HCN. What's wrong with this? It has 3 elements. It's not binary, is it?
No.
Is this what you're asking me about?
5.
Awesome. Now, here's why this is going to be included. What is the name of this ion? What about this one? What about this one? What about this one? Great. What's the name of CN? Cyanide. That's why we're including it in this group. It's an exception because, as Maddie just said, it's not binary, right? However, the name of the CN ion is cyanide, so we're going to treat it the same way. So, anyone want to take a stab? Did anyone even try it?
I did it.
What'd you get?
Hydrocyanic.
That's exactly right. Hydrocyanic acid. So even though it violates the rule, it's easy. Does anyone have hydrocyanic acid? Awesome, look at that.
You gotta bend the rule.
H2S. This will be interesting to see what happens here. Anyone feel confident? Does anyone feel that, no, I don't think it's right, but I'm going to say it anyway because I don't care? Go ahead, Brandon, or Braden.
Dihydro.
Oh, wait, sorry about that. Wait, Brandon, I'm going to go ahead, Brandon.
Dihydrosulfuric acid.
What were you going to say? Okay. And you guys did, how many of you started off with dihydro? Okay. You guys missed a very key piece of information that I said really early. I said we are going to treat these as ionic compounds. And I also said, what's the charge on the hydrogen ions? And everybody said 1+. So we're going to use the prefix di. No. There's only one substance that can be formed between hydrogen and sulfur, and that's H2S. So we just call this hydrosulfuric acid. HF. Anyone?
Hydrofluoric
Hydrofluoric. Now, is anyone familiar with hydrofluoric acid?
Yeah, I know I came from.
Has anyone watched Breaking Bad before?
Oh yeah.
That's, yeah.
Yeah, I know her.
All right, moving on. Okay. I didn't put it there. I didn't. Why would I put it? I didn't put it there. All right, moving on. What time is it? Dang it. Okay, I want to briefly go through that last piece there. Now, there are, I believe, 4 other substances there that are acids. How do we know they're acids? Because they start with hydrogen, okay? But what other element appears to be there that was not in any of these? Oxygen. So that means all of these have polyatomic ions. Okay? So basically what we have there is the hypochlorite ion, ClO. We have the chlorite ion, ClO2. We have the chlorate ion, ClO3. And the perchlorate ion, ClO4, represented all right there, right? All of those are polyatomic ions. These are actually easier because you don't have to use the prefix hydro. Okay, so all you do is if the name of the ion ends in ITE, you change it to OUS and write the word acid. So for example, chlorite becomes chlorus acid. Chlorate becomes chloric acid. That's not hard, is it? And that's it. We're done with acids. How do your brains feel? But wait, we need to practice. Okay, I don't